If you have built a raised bed using the traditional horizontal layering method, compost, topsoil, planting mix stacked in flat layers, and watched it underperform through the first growing season, the reason is structural. Horizontal layers create interface zones between materials of different texture and density that slow water movement, restrict root penetration, and create low oxygen conditions that suppress biological activity. There is a faster approach that bypasses those dead zones entirely, vertical trenching combined with a fermented fruit catalyst that draws earthworms upward from the subsoil and transforms your raised bed into a nutrient-dense biological engine before the first seedling goes in. The lasagna composting model works, but not on a spring timeline. Horizontal layers take weeks to months to break down into plant-available nutrients, and during that period they create anaerobic pockets at layer boundaries where water pools and oxygen is excluded. These zones suppress the aerobic bacteria and mycorrhizal fungi responsible for nutrient cycling and root colonization. The deep core of most horizontally layered beds receives almost no biological activity in its first season, sitting directly below where the majority of root growth will occur. Vertical trenching reverses this by driving organic matter and biological catalysts straight into that core zone, delivering energy directly to the depth where roots will grow. Using a narrow trowel or rebar, create vertical columns in the center of your raised bed approximately 6 to 8 inches apart, driving each to within 2 inches of the bed base. Each column should be 1 to 2 inches in diameter, narrow enough to avoid disrupting the surrounding soil but wide enough to accept a packed charge of organic matter. Fill with a mix of nitrogen-rich green material, grass clippings, chopped comfrey, or vegetable scraps, and a small proportion of carbon material such as shredded paper, at roughly 3 parts green to 1 part brown. This ratio keeps the carbon to nitrogen balance close enough to neutral that microbial breakdown begins within 48 hours without nitrogen immobilization. The biological catalyst that ignites the system is fermented fruit skin, banana peels, mango skins, citrus pith, or any high-sugar fruit waste fermented at room temperature for 24 to 48 hours in dechlorinated water. During fermentation, simple sugars break down into organic acids and alcohols that are far more detectable to soil organisms than raw sugars. Research on earthworm chemoreception confirms that fermented compounds produce significantly stronger migration responses in Lumbricus terrestris and Aparectodia caliginosa than fresh unfermented material. Place 2 to 3 tablespoons of the fermented slurry at the base of each column before packing the green-brown mix above it. The fermented base creates the scent trail that draws deep-dwelling earthworms upward while the organic matter above provides the nitrogen feast that keeps them there. Seal each column with a plug of fine compost or worm castings pressed flush with the surface. This cap traps microbial heat and maintains the humid environment that drives rapid decomposition. Temperature inside a sealed column runs 1 to 3 degrees Celsius above the surrounding bed within 48 hours, confirming the microbial engine has fired. Plant 7 to 10 days after installation. By this point decomposition has stabilized, earthworms are actively tunneling and aerating, and nutrient-rich leachate has begun moving into the root zone. Position transplants 4 to 6 inches from the column lines so roots grow toward the columns rather than directly above them, where decomposition heat and carbon dioxide can stress young root tissue in the first week. Subscribe to Natural Crops and AMP, Soil Hub on YouTube for more practical, evidence-based methods that build living soil from the inside out. Subscribe. Share. Build the soil engine your raised bed deserves.